Ian is now going to take those across and show you how to do some interactive mapping examples, interpolating values on a map, and show you how to add contour lines on a map, and show you how to transform different coordinate reference systems, picking off one reference system, mapping it to another, and then looking at overlays and calculating what's inside of different regions of a graph, of a map. So this combines some of the data function and expression constructs that Jagrita just showed you how to set up and apply those in a mapping context. And we will provide you Jagrita and Ian's examples, and you can work along with these in your own time. We've tried to make the examples very foundational and exemplary so that these are examples that will get you started down a particular direction that you can easily add on to. So Steve, let's give the ball over to Ian.
Yep. Okay, great. Yeah, thanks, Michael, for the introduction. So as Michael said, I'll present some examples that use the same capabilities that Jagrita showed, but they're applied to geospatial data tasks. And this example might be familiar to some folks in the energy industry, some of the same kind of problems you might work with day-to-day in upstream energy. So in this case, I have some data on the thicknesses of different kinds of geological layers in Western Canada area, most of it in the Alberta province. And I'm looking at just one particular layer called the Lower Manville. And you can see that what this is measurements of thickness of a specific geological layer. And a lot of the values at specific points are missing. So we've got, a good number of measurements here, but then somewhat larger number of missing values. And often in this kind of example, we're interested in understanding what are the interpolated values of the thickness of this layer at the points at which we don't have those measurements. So I will show how you can do that using TER expression functions, some of the same capabilities that Jagrita showed. So within Spotfire, in the data function properties dialog in the edit menu, there's a tab here called expression functions. And this is the interface through which you can define new expression functions that become part of the expression language in Spotfire. And you can do this using the R language. So you can create an expression function with a specific name, description, and then an R script that defines how it works. And you can give it a category and specify what sort of return type it has. And as Jagrita and Michael both said, expression functions are limited to returning one column of output and inputting one or more columns. So in this case, I've added an expression function here called interpolate smooth surface. And what this does is inputs X and Y coordinates and then some Z value, which is just a value at those X and Y coordinates. And then also a smoothness parameter. And then it uses the low S function and some other functions here to give you back interpolated values for all the points in your data set, including the ones where the data is missing. So the name of this function again is interpolate smooth surface. So what I can do here is take my missing values and I can color them using an expression. And when I search in the functions area here of the expression, the custom expression dialog, I can see my interpolate smooth surface function. You'd also see any other functions that you define through that data functions interface here, and you can see the documentation that I added. So I can then insert this function and finish passing the required parameters to it, which I can see are X, Y, and the X and Y coordinates, the Z value, and then my smoothness parameters. So the longitude, the latitude, the specific value that I'm displaying here is the Manville layer thickness. And then I have a document property here called theta that gives it's the smoothing parameter that I'd like to use. And then I can call this interpolated thickness in meters. So then when I click OK, Spotfire goes ahead and runs that expression on TER using the data from Spotfire, and then creates the coloring for this set of points, which previously had a lot of missing values in it. So this is a really powerful capability that we use in lots of real situations. Just again, starting off with a smaller number of points, and then interpolating values for a much larger number of points. From there, I'll show how you can also go ahead and add contour lines on top of this visualization. And this is a capability that can't be done using these expression functions, but can be done using data functions, which Jagrta also showed. So I'm going to insert a data function that I have in my library called contour lines. And then when you insert a data function, a data function is something that is generally created by a data scientist or statistician type user. But this interface that you'll see here, to apply a data function within a Spotfire analysis, this is a task that you don't need to know how to code in R to do. You just need to be able to follow these simple instructions that the author of the data function has created. So, in the input tab, I can see that I need to map these parameters according to descriptions. So we have X. This is a column of X coordinates or longitudes. I'll select my longitude column. The Y column is latitudes. The Z value is the data that I'm going to be calculating the contour lines based on. Again, it's the thickness of that one layer. And then this is the smoothing parameter, which I have stored in this document properties data. Then I'll output a new table containing contour lines as the instructions tell me to do. And I'll have this refresh automatically. So just through that small number of steps, I now have a new table added to my Spotfire analysis called contour lines. I can drag this over and add it as a new feature layer on my map. And you can see now the contour lines are visible on the map. I'll just change this so it's colored by the level of the contour lines. And I'll increase the thickness a little bit of these lines so you can see them better. Now I can change the smoothing parameter, and the contour lines are, you can see them in real-time refresh according to the, the smoothness level that we desire. So this is a fully general sort of capability that can be applied in, all sorts of situations. It doesn't have to be geological data. It could be anything that you can plot on a map. All right, so from there I'll show a couple other capabilities, as Michael mentioned. A common situation when you are working with geospatial data in Spotfire is that you load in a shapefile. So when you add a data table from a file in Spotfire, one of the options is to add shapefiles, which have the .shp extension. These are standard representations of polygons, lines, other shapes that Spotfire can load. So I have a shapefile that contains some boundaries of natural regions of the Alberta province in Canada, and I might be interested in mashing this up with my isopoc data, the data on the thicknesses of these geographical layers. So let's take a look at this data we imported, and then let's put it on a map. The problem is when I put this data on a map, Spotfire tells me you can't show the data in this coordinate reference system. So this data is represented in a shapefile using a coordinate reference system that is not compatible with Spotfire. It's a special coordinate reference system that's relevant only for this local area in Canada. So we would like to do something about this, and in fact we can. So I have a data function which we've shared with you, and I'll tell you how to get it afterwards, that is called transform coordinate reference systems, or transform CRS for an imported shapefile. So I'm going to select that and insert it into my Spotfire analysis. And then again, we just have to simply follow instructions as before to apply this particular data function. So it asks us for the table imported from a shapefile. So I can select the table that we just imported, and then I'll select all columns by putting the wildcard character in the search expression. Then it asks me for a EPSG code identifying the coordinate reference system of the input shapes. So this is explained in the description that you can look up EPSG codes at this website. So I'll show you how to use that. If you're working with a shapefile and you get that error in Spotfire, what you can do is go to this website, prj2epsg.org, and you can upload the projection definition that comes with your shapefile. When you download a shapefile from anywhere, it comes with a .shp file, That's what we loaded into Spotfire. It also comes with a .prj file that defines what is the coordinate reference system of this shapefile. So if you select that and then upload it to this PRJ2 EPSG site and hit convert, it then gives you a code, 3400 in this case. It's typically a 4-digit number that defines the coordinate reference system here. So I know that is the input EPSG code. So I'll go ahead back to my example and input 3400 as that code. Then the output code defining the coordinate reference system that I'd like to convert this data to, it says in the description that you should use 4326 for standard latitude, longitude coordinates. So I'll use that, 4326. All right, and then I'll output my data to a new table called natural regions transformed. All right, and then when I click OK, Spotfire will run this tear data function to transform the coordinates of this this shapefile. And then I can see that there's a new table in my analysis called natural regions transformed. When I convert this to a map, now we can see the error has gone away and Spotfire understands where this data is and can display it on top of the base map. From there, we could, for instance, also add the ISOPAC data on top of, overlaid on top of the natural layers. And this brings up, on top of the natural areas, excuse me, this brings up another common task that is often needed when you're working with geospatial data in Spotfire. If you have polygons defining areas, and you also have points, in this case defining, measurements of thickness of geological layers, you often want to understand where, in which of these areas do each of these points exist. And this can be done using another data function that we'll provide to you. So I'll show you how to apply this data function. And this action is sometimes called geofencing or spatial overlay, identifying which points are inside which polygons. So I'll add a data function through insert data function, and I will find it, geofencing, whoops, sorry, it's called points and polygons. And there's two versions of this, one that works with Cartesian coordinates for indoor spaces, say, or sports arenas, and one that works for latitude, longitude coordinates. So I'll select that one. And again, we just have to follow a few simple steps in order to input both our shapes and our points, and then to output the identifiers of the shapes that each point is in. So this is a column representing the polygons. So I'll get that from here. It's called geometry in our natural regions table. This is the column of the identifiers of the polygons. I'll get that from the NSR name column. And then this is a column of longitudes of points. These are the measurement points. I'll take that from the ISOPAC values table, longitude column, and this is the latitudes of our points. I'll take that from the ISOPAC values latitude column. Then I need to output a point back to a column, back to our ISOPAC values table that specifies which area each point is in. So when I click OK, this data function runs. And what I am then able to do after it runs is to color the points based on, based on the identification of the natural area in which the points are located. So I did a better job of coloring this in another version of this. Whoops, sorry. You can see that I'm able to color the points, to exactly match the underlying areas. So this is a very useful piece of functionality. The usefulness of it extends beyond beyond this sort of energy-focused example. Often you have points representing customers within certain catchment areas, and you want to identify, which catchment area is that customer in. So this data function can be used for that purpose, as well as for the kind of purpose that I showed here today. All right, so that's those are the demos that I wanted to show. These data functions are .sfd files. To use them in Spotfire, you go to the Tools menu, click Register Data Functions, click the Import button, and then that gives you a file browser where you can import a .sfd file. After importing it, then you click Run, and you get the Edit Parameters dialog to apply it inside your analysis. So we hope that you get some value out of those data functions that are available there.
Ian, can you just show that, importing that again, just show that the imported file?
Yep.
After you did, just kind of went away very quickly.
Yep, sure. So you go to Tools, Register Data Functions in Spotfire, and you click the Import button. And then you select a .sfd file. I'll use this points and polygons one here. This opens up the data function. You can see the R code associated with it. From there, you click the Run button. Which you can
also save this to the library, right?
Exactly, yeah. The Run button is used to apply this data function within the particular Spotfire analysis that you're using. If you're online and logged into a Spotfire server, you can also click Save As and save this data function to your library so that not just you can use it, but anyone else who has access to that library folder could.
Yeah, very good. Thanks, Ian. And yeah, as Ian was saying, we use this type of thing. There's a Cartesian version of this as well as a longitude-latitude version, and we can overlay, people in regions or restaurants in regions, or we can do people in stadiums, or whatever you define as your shapefile that has that you're interested in. Could be a layout of a shop, of a retail store. You can start to understand spatial patterns of who's in what region, that sort of thing. That's very general capability shown today in so players on a basketball court, for example. You can do it that way. And actually, we've got a number of examples where we actually do have an example of players on a basketball court. We had an example of shots taken from different regions of the basketball court and their success rate. Or, you can do regions in a stadium. Aisles in a retail store. So we've given the example today of regions on a geological regions on a map, but just imagine you can apply that to any diagram of any process and calculate statistics on regions of a process. Okay, so let me just...
Hi, Michael.
Hey, yeah.
There's a question regarding, do we support other map providers?
Yeah, Ian can talk to that. We can answer that now, I guess. We're going to take questions at the end, but Ian, go ahead and talk a little bit about Esri and so on.
Right. So inside of Spotfire, we have a specific base map, and it's configurable. And this base map is something Tibco provides, but it derives from the OpenStreetMaps project. So you can add a map layer inside Spotfire, and then you can choose, some parameters of the map. In terms of external providers, we do support external maps if they are served via the WMS or Web Map Services Protocol. This allows you to add a specific URL of a WMS server, and then that WMS map layer will be rendered on the Spotfire map. And this is something that you can use to find different kinds of base layers, as well as things like weather radar and all sorts of other features can be added to your map through that mechanism.
And so, Ian, on your current map, you have a WMS layer, but you also have two map layers, one of which was derived from a shapefile, and then you have a couple of other layers that were derived from points that you had, data points. Can you just discuss the different layers you have on the map right now?
Right. Yeah. There's a number of layers that are possible. The most common ones you'll see when you first create a Spotfire map are you always get the base layer. And if you have data that represents points, you see a marker layer, it's called. That's the layer rendering the points. And if you have data that's been imported from a shapefile that represents polygons, that creates a feature layer, which you can see, rendering these shapes. And then again, the WMS layer is another possibility.
Very good. Yeah. So Ian took us through a number of things in a Spotfire expression on the fly. The script was interpreted inside the tear engine, and we got estimated some missing values. Ian then did a data function to apply some lines on top of a map, and then he converted one system to another. You know, the Earth is broken up into a bunch of different local flat regions, and if you want to put them on a more global representation, you have to convert. Ian showed how easy it is to convert that, and then he did the overlay and assign different points data points he had on one layer of the map into polygons defined by another layer in the map. So there's really no end to what you can do in this way, and just also think about, like I said, this being a shop floor or some other representation that we don't have to do lat longs. We can do any kind of underlying reference location system. Basketball courts was one of the examples given.